Welcome to the channel. Here, the function of a, b, c is given for the terms 1, 2, 4 and 6. We have to implement the same function using multiplexer. So first of all, understand what is min term and max terms in order to solve this problem. Here, summation symbol is for min term. And the equation always in sum of product form. The equation example is y is equal to AB plus BC. So this is sum of product form. And the symbol pi is for max term. And this is product of sum form. For example, y is equal to a plus b multiplied with another bracket b plus c. So this is product of sum of these two terms. In the mean term, a is equal to 1 and a bar is equal to 0. In max term, a is equal to 0 and a bar is equal to 1. In this case, min terms are given 1, 2, 4 and 6. For example, consider 4:1 marks, which means that there are 4 input and 1 output. So multiplexer is nothing but many to 1 number of inputs, and out of that 1 will be selected as an output based on select lines. This is Y, this is I0, this is I1, this is I2, and last one is I3. So this is S0 and this is S1. So these are select lines. So here 2 raised to n, which is equal to 4, and n is nothing but the number of select lines. In this case, the value of n is 2, and that is the reason the multiplexer always in multiple of 2. And for example, for 2:1 marks, the value of n is 1, and for 8:1 marks, the value of n, which is equal to 3. This is all about multiplexer. So multiplexer is simply selecting the one output out of the number of inputs based on the select lines. So this is 4:1 multiplexer, which means that there are 4 inputs, 2 select lines and 1 output, and based on the value of select lines, one of the input will be switched towards output side as an output. Now come to the solution of this problem. The function of ABC is given for the min terms 1, 2, 4 and 6. So I write A, B and C terms. A is MSB, C is LSB, and I represent the min terms 1, 2, 4 and 6 in binary form. So 1 means 0, 0, 1, 2 means 0, 1, 0, 4 means 1, 0, 0, and last 6 means in the binary form 1, 1, 0. Now if we observe the value of A and B, so in the first term we are getting 0, 0, for the second term 0, 1, for third term 1, 0, and for the last term we are getting 1, 1, which means that we can choose these two as the select lines. Here all possibilities are given for the two terms A and B, 0, 0, 0, 1, 1, 0 and 1, 1. So based on these possibilities, we can select the inputs. Here, I0, I1, I2 and I3 can be designed from the remaining LSB term C. 1 means in the mean term, we can take it is C. And for 0, we can take C bar. Same for 4, C bar. And for 6, in the last term, LSB term, we are getting C bar. Now I consider this is A, this is B. The first condition is 0, 0. Second condition is 0, 1. Third condition is 1, 0. And fourth condition is 1, 1. For the first condition, I0 will be selected. For the second condition, I1 will be selected. For the third, I2. And for the last condition, I3 will be selected. And in order to select the inputs, we are considering the C value. Here, 0, 0 means I0. And for I0, value is C. So directly we can connect C to the I0. For 0, 1, 1, 0 and 1, 1, we are considering I1, I2 and I3. And the value of C is same, which means 0, 0, 0 and C bar. So here I connect one inverter. An inversion of C is connected to I1, I2 and I3. Now the circuit is completed. C will be selected, which is connected to I0 as an output if A and B 0, 0. And for the rest of the conditions like 0, 1, 1, 0 and 1, 1, the common value is C bar, which will be selected as an output based on the A and B conditions when A and B are 0, 1, 1, 0 and 1, 1. So this is the solution of this problem. The same terms or function can be designed using 2:1 multiplexer also. Thank you.